Hello, this is Joe Montano, and this is a video about the Baldi Stava dam collapse. The disaster happened during July 1985, in northern Italy in a town called Stava. The thing about these disasters is that it literally erased a whole town from the map and killing more than 200 people. The correct number will be 268 people um, died because of this collapse. And also, most of the houses were totally destroyed by the flood that happened. What happened? First, let's start with the dam itself. What was its purpose? This dam was constructed the for the waste of a mining facility close by. The waste was in composition of um, silt, sand, and water. The purpose of the dam was because they couldn't throw these waste through the valley to get into the river because of the amount of contaminants that these have. So the dam was designed to um, make the water stay still inside the dam with the waste. So then every heavy material will separate and go down to the dam, and the water will stay still in the top. So then this water that doesn't have the contaminants will go out of the dam and then will connect to a stream of water, and because they don't have any have low contaminants, it will not create a hazard to the town itself. Uh, so the reason of the failure and the thing about this dam was that was situated in a valley, but the valley was really steep. So after the collapse, the waste and the debris took a lot of momentum from the really steep slope of this valley, which in terms with this speed destroy any house in their way. Also, um, an amount of 268 people died because of the disaster. And like I said before, it literally erased a whole town from the map. So the main reasons of why this happened. One was the thing about this dam was that was built in a really steep man and wasn't built properly, uh, cutting the land in order to have a flat surface in which the dam will be supported. Then the dam was built over this steep incline valley, which is a major hazard in terms of after a certain amount of weight was in the dam, and also the fact that this dam was uh, the first dam was extended upwards to support more waste. And then this obviously will create a cause of failure, which in turns is what happened in this case. The second was the nature of the soil. Even though being not being in a flat surface is really bad, the fact that it was in a water saturated soil is a really um, high risk in terms of any structure, and even more in a steep surface, because there are many things that even for a house have to go in order from the foundation, even creating a steep foundation in order to be stable enough for a house in a water saturated soil. And the third one was incorrect inspections. The thing about this dam was that the inspect one of the inspections, many of the inspections says about the low maintenance of the dam, but also the inspection for the soil was done by an engineer from the company itself. So we know there are some issues there because they didn't want to pay the money for the inspections for the soil for the dam, because it will cost a lot of money. So the way they tested the soil in the dam was just taking a steel rod and pushing it into the ground, which we know that's a crazy idea for an inspection of something of this magnitude and high risks and hazard. I, the thing about the the interesting part about this case itself, it was that was not even the only one that was happening. Many cases of dams around the world from the same things, mining facilities, um, many mining facilities using dam for the waste uh, during the 1985 and 1990s. Um, Many facilities around the world have similar amount of problems and floods because of similar stuff like this, because the thing about this waste that is really heavy, so if it's not built properly, and it can create some problems, and also how some of these materials can be even corroding the the dam itself, if, because they use cheap materials in many of these dams around the world. So now there are many regulations, and also the inspections. The inspection itself, more of the inspections already existed before these disasters. However, they were not taken that seriously. Anyone can make this in, an engineer can make the inspection itself, which is crazy in these terms of the dam, and was not really a major um there were not really a big push for the inspections of these dams. Because of the same thing, dams existed for a very long time, and many of these still exist, and many dams still exist today, for even a millennia ago. So they didn't take this seriously because they were things that were always there, like the bridges. So after this, many solutions came out, and more like the solution is more taking into account many risks of these waste materials in dams. So during the design process, there are many things that have to be taken into account. One is will be the risk analysis and risk system or risk estimation, which takes into account what is going to be inside the dam, the place that the dam is situated, and which risk any factor can give to the dam at any moment. So we can try to take it to the side and reinforce this dam in order to in order sorry about that, in order to all right, so we can every part of the dam and take into account any type of risk that may come in order to reinforce the dam, so any problem will not happen. The second one will be potential failure of modes. The modes are the parts that make the flow of the liquid material uh, pass through the dam itself. In this case, it will be the water, because we want to uh, lift the and the heavy materials, um, the any type of sediments in the dam, and the water itself go out of the dam. So this must have to also, we have to take into account any type of risk that these modes can have, because if they're too small, and they can a small little flow of water will go out of the dam, so they can be they can this can create overflowing of the dam. And also if it's too big and or too large, can even the same pressure of the water can even take some of these sediments and waste materials that we don't want in our streams of water go out of the dam. Also will be the screening level. rates estimations, which this happens during the whole process, design process and construction process many times, because the screening is more to uh, in case of any type of risk which was not estimated at the beginning because maybe go under the radar, or maybe after the design there were other factors because of the land and everything like that, that many maybe another inspection shows a little something different from the estimation of the design, so this have to be taken into account. Then, as I said before, multiple inspections have to be made. The soil itself is stable enough for a dam. If they need any type of reinforcements for this, this if the place where the dam is flat enough, the materials that the dam that are using the dam, if any type of waste that will go inside the dam are corrosive to the dam, everything have to be inspected in order to ensure that everything is okay, to prevent any type of failure that can create another catastrophe as the Stava collapse. And the main thing is like being built in a flat terrain and having the amount of reinforcements for the soul, the amount of having a good foundation for the dam, everything that comes to this, because we have to ensure that the dam will not, in case of anything, will not move itself, the structure, in which can create a flooding or over flooding of the dam or anything like that. And so that will be all about the Stava collapse. Thank you very much.